Hello, we're going to do the battery maintenance and testing activity now. Of utmost importance is whenever you're working on a battery, having this proper personal protective equipment, including glasses, clothes that you don't mind having holes burrowed through them with the acid if you spill some, and some chemical resistant gloves that I'll be wearing when we're messing around the acid. So what you should have now is you should have your lab downloaded and you should be able to go through the activity with me. Okay, so the first thing that lab asks in part 1 is the date tested by battery make, specified voltage, CCA and such. Okay, so going through that, the date is April 1st or whatever you're doing it, tested by all of us. Battery make, this is an interstate battery. Specified voltage, it's a 12 volt battery. Battery CCA, the cold cranking amps is 540 CCAs. And battery ID, that's not really applicable with how we're doing this lab this time. So now we're going to visually evaluate the condition of the battery. Are the terminals corroded? If so, how badly? Not sure how well you're going to see this, but they are slightly corroded. We'll be able to clean them down at a later point. In order to clean them down in the battery terminals, you would use a battery terminal brush. Often has this to do the cable and to go in the cable, and then here there's a wire brush that'll do the terminal. I'm not going to do that right now though. Okay, is the top of the battery dirty? Heck yes. Yes, definitely. And there's some acid dripped on it. Some of it is when I've been doing some of these tests, and some of it was already there. Okay, are the vents clogged? No, the vents are not clogged. Are the cell covers raised? That would mean it had frozen and thawed and maybe just displaced the case. No, this battery is still good and working in that regards. And is a case cracked or deformed? No, it is not. Okay. Evaluate the electrolyte and determine its specific gravity. We have several things to determine the specific gravity and the quality of electrolyte. I have 3 tools here, actually 2 tools. One is a hydrometer. You would use this. This is a pretty cheap one, nothing fancy, but it has the numbers listed on it. Good, $6, works pretty well. Problem with this one is there's a lot of glass here and you have to be very careful with it. They also sell plastic ones like this. This is actually a coolant tester, but it works the same darn way. A little coolant's dropping out of that. They just put different stickers on it. And the best way of doing it is, and I got this through the school, a hydrometer. A hydrometer that is, actually it's not a hydrometer, it's a refractometer. And this one will put a drop of the electrolyte on there, and then we will do it. Okay, in order to do that, safety is of utmost importance. So I'm going to put on gloves, stand up, we're going to walk through. We'll just do one cell. So what you do on this is, I've already loosened up the cells. You take off this, use a little pipette. Pipette, you go in and you take a bit of acid out. You put just a drop, it doesn't have to be a lot, put a drop on the lens, close it up, and then you look through and see where it reads. This cell is reading 1.20. Okay, so that's really good. Actually, it's not really good, it's slightly discharged, but the process is good. So, in order to do this, I have gone through and I have recorded them all. So, here we go. Cell number 1, the specific gravity is 1.18. Cell number 2 is 1.20, the one we just did. Cell 3 is 1.21. Cell 4 was also 1.21. Cell 5 is 1.23. And cell 6 is 1.21. So that's saying the battery is not particularly charged. Speaking on that for just a moment, a fully charged battery should have a specific gravity at 80 degrees of 1.265. It's 60 degrees in here I did with my thermometer, and it should be 1.27. So 1.20 is showing it's like a very discharged battery. And you could look on that chart that is in Dr. Hardin's presentations to see how much, as you should. Okay, so then nextly, I would like to do the open circuit voltage test. Question number 3, I believe. Open circuit voltage is pretty darn simple, in which you just go to DC. Unfortunately, with how I'm using the phone, it's going to be in backwards from how you would see it, so you're going to have to trust me on this, which I know is probably never a good idea. But we go through here, and it says 12.58 volts. So that's pretty much 100% charged battery. So a little bit of a conflict there in that we said it was the electrolyte's not charged very well, but the open source voltage or the open circuit voltage is at 12.6. So that's an interesting one that I want you guys to think about. Okay, maximum case leakage, that would be where you would take your multimeter and going around and test from positive, going around the battery, and with that I got about 200 to 300 millivolts, except when I went into the acid, where the acid's leaking along here a little bit. Shouldn't do that without gloves, but I did, and that is, then the voltage is much higher. You'd want to clean that off with some baking soda. Okay, and now I guess we should do test number 4, the microwatt test. Now this is putting a load on the battery. So instead of just having a open circuit voltage, which we did there, which tells us that we have a certain amount of voltage, but it does not really tell us. It really does not tell us how much amperage we have at that voltage. We have ways of doing load testing, in which we put a load on this and then see what it rates at. So two or three major ways of doing it. The one you can get in an auto parts store for a pretty affordable price, and it works relatively well, is just a battery tester like this with 2 cables. This one does 6 volt and 12 volt, and you just put it on. I'll do it quickly. Put positive, negative, make sure it's on 12 volts, and then you just hit this switch, and, then you just hit this switch at the bottom that puts trying to get it so it's not so flashy, put a load on it, and the needle goes down. It says the battery is okay. Keep that loose. A better way of doing it is with a microwatt or a carbon pile tester. And this tool is the schools, and you can use it in a variety of ways. It tests starting circuits, it tests cranking circuits, charging circuits, and batteries. So this one's pretty easy. You just put the red cable on the positive. Should take these cables down, but it'll be fine for what we're doing today. Put it on, and that goes through a bunch of screens. I'll talk you through them. So the first one is it's checking connections. The first one is what's battery size. This is a 540 cold cranking amp, so I have that set already. And you just click yes. I don't know if you can see that, but enter temperature. It is about 50 degrees, 60 degrees, so I'm going to go to 50, be a little harder on the test. And it immediately say, battery is bad. And then we can look at it. So it says it has 12.58 volts. It has 347 cranking amps, but only 64% of the rated capacity. The battery impedance is 9.3 milliohms. So it's saying the battery is bad. I think the battery would have to be much greater than 64% of the cold cranking amps. So that's another way of doing a battery test. Okay, yeah, so the answers are there where it's rated 540. It came at 347. Percent of capacity 64%, and it's 9.3 milliohms of battery impedance. The battery impedance is basically more impedance is bad. As batteries age, the impedance, the internal resistance goes up and up. Okay, that's about what I got for you. You walked through all of the tests now, looked at the battery inspection. We would clean them off now, get some baking soda on there, and we should be about done. Okay, thank you.